veterinarians. So let's go ahead to 3A. And on problem 3 it says a claim is made that the average amount of calories in a male's diet per day is 1,500. You don't believe this claim. Well, that would make the null hypothesis that mu, since we're dealing with averages, equals 1,500. The alternate hypothesis would just be that mu does not equal 1,500. So this would be a two-tailed test. You sample 100 males, so that's your N, and you find their average calorie intake to be 1,550 with a standard deviation of 200 calories, and it says test this claim at the 0.05 alpha level. So what we'll do here is go back to the 1 mu sheet, since it's dealing with averages, and let's go up to the top, and this is a two-tailed test. So what we'll need to do is put our information in here, and the alpha level on this particular problem was, I believe, 0.05. We can double check that in a second. The mu claim mean was 1,500. The X bar was 1,550, and the standard deviation was 200. And let's double check and see what the alpha level was in the N. And on this problem, the N was 100, and the alpha level was 0.05. Okay. Okay, so 100 was the sample size, and the alpha was 0.05. Well, at this point, we get a reject the null hypothesis. Here's your test statistic, 2 critical values, and your p-value. And since your p-value is less than your alpha level, you reject the null hypothesis. Also, anytime your test statistics falls into your rejection regions, in other words, if it's greater than your positive 1.96 or less than negative 1.96, we would reject the null hypothesis. Because down on this picture here, our test statistic of 2.5 falls right here into that rejection region, right there. And we could see that better probably if we started at, let's say, 0, because we can see the right-hand side there a little bit better. In fact, let's start a little bit farther up, like at 1. And now you can see that test statistic falling into that rejection region. So we do reject the null hypothesis at the 0.05 alpha level. And we would say at the 0.05 alpha level, I was able to show that the average calorie intake for males per day is significantly greater than 1,500. Now, this was a two-tailed test. You might say, well, how do you know that it's significantly greater? And the reason I know it's significantly greater is because, first of all, it's rejected the null hypothesis, and also my test statistic rejected it on the upper side. My X bar is greater than my mu, and it's significantly greater because I rejected the null hypothesis. And again, I rejected it on the upper side, so that's why I can say that it's significantly greater than 1,500. Okay, on part B, it says run this with p-values, and again, since your p-value 0.0141 is less than 0.05, that's why I reject it. On part C, it says run the same test at a 0.01 alpha level, and if you do that, you get do not reject the null hypothesis because my p-value is not less than my alpha level. So on part D, it says how would you summarize it on a project, or summarize it at the most significant alpha level? And the most significant alpha level would actually be 0.05 because that's the lowest alpha level that you can reject the null hypothesis. On part E, it wants you to get a 95% confidence interval. So let's go down here and do that. The confidence level is 0.95. The N was 100. The X bar was 1,550. And the standard deviation was 200. And we get all of our information here, and here's my confidence level. And I could say I am 95% sure that the average calorie intake for males per day is between 1,510 and 1,589 calories per day. And that would be my 95% confidence interval. On problem, let's see where we are here. So let's go through these. Actually, it wasn't a confidence interval in problem 3E. Problem 3E is actually a sample size question. So at least we have the confidence interval done if that would come up. But on 3E it says using the information from 3A, how many more males would have to be surveyed to be 95% sure your estimate is within 10 calories. So really this is a sample size determination for mu. So we want to go to that mu, 1 mu Excel sheet. I'm waiting for it to get there. There we go. And scroll down to sample sizes, and we'll put in our confidence level here, which was 0.95. Our margin of error was told to be within 10 calories, so your margin of error is 10, and your sample standard deviation is 200. So you get a total of 1537. Well, remember we already sampled 100 males to begin with, so how many more you would need to sample, we'll subtract the 100 off, and you get 1437. Part F says to estimate the standard deviation. Given that the high intake for males is 3,000 calories and the low is 1,000 calories, estimate the standard deviation. This is using an approximation for the standard deviation where you take the range divided by 4. It doesn't give you exactly the standard deviation, but sometimes that's all you have to go by. So the range, 3,000 minus 1,000 is 2,000, and 2,000 divided by 4 would be 500. So your estimate for your standard deviation would be 500. On G, it says use your answer to 3F, this one, to determine how many males you would need to sample to be within 10 calories of the true average with a 95% confidence interval. So this is a sample size question again, and the only thing that changes is now we're putting in the standard deviation of 500. And we're assuming that we don't have a previous estimate, so it would take a total of 9,604 males to be sampled. And really that's everything on the practice test.